In this video, I want to talk about how to write hypothesis statements. And hypothesis statements can be used in different types of testing. For example, with a normal distribution using the Z statistic, with the T statistic, or even with other types of tests. But this one will apply to everything. So what we want to do is we will have a null and an alternate hypothesis. And in every case, the null hypothesis is going to state the status quo. It's what everybody currently accepts as being true. And it's basically a claim that there is no difference between the population parameter and the sample statistic. And the parameter that we're usually looking at is the mean. Now, the alternate hypothesis is usually called the researcher's claim. And this represents what you or anyone else that's doing a study hopes to show is true based on the data collected. Now, when I say true, remember everything in statistics is based on probability. And so basically what we're saying, if we support the alternate hypothesis, is that based on the data we collected, the null hypothesis is no longer true. So in the case of the alternate hypothesis, it contradicts the null hypothesis, and so what we are concluding is that there is a difference between the population parameter and the sample statistic. So we're going to go through a couple examples, and we're going to write out the null and the alternate hypothesis for each one of these. In this particular example, we have the survey of study habits and attitudes of students toward school. And the scores range from 0 to 200 with a mean of 115 and a standard deviation of about 30. Now, in this instance, we have a teacher that suspects that the mean, mu, for older students is higher than 115. So what we want to do in this case is to state the null and the alternate hypothesis. Now, the researcher's hypothesis is that the mean is in older students is higher than 115. So that is one of the things that's very important. Now, based on what everyone believes is true, the average or the mean is 115. And we have a standard deviation of about 130. Now, of 30. The standard deviation will enter into our hypothesis test, but it does not enter into our hypothesis statement. So we have the null hypothesis, and that null hypothesis will state the current thinking. And the current thinking based on what we just looked at is that the mean is 115. The alternate hypothesis is going to claim what the teacher believes. And the teacher believes that the mean is higher than or greater than 115. So our hypotheses would be the null is that mu is equal to 115, and the alternate would be that mu is greater than 115. Okay, here's our second example. It says that the average income of American women who work full-time but only have a high school diploma is $31,666. Now, you think that the graduates from your local high school have a different average income. So you think that the students that graduated from your local high school but only have a high school diploma and work full-time is different from the national average. All right, so if we go through and we look at it, the national average is 31,666. Now that is what everyone believes to be true. But you, as a researcher, think that the people that graduated from your high school have a different average salary than the national average. Okay, so if we look at the null hypothesis, this would support what everybody believes, and that is that the national average is $31,666. The alternate hypothesis will support what you think is true, and you think that the salary is different from. Now, the word different from in math terms is going to mean not equal to. So here are our hypotheses. The null hypothesis is that the mean is 31,666. The alternate hypothesis is the mean is not equal to 31,666. And just by way of an aside, when we actually go through and perform a hypothesis test, this is called a two-tailed test, because we are actually testing whether the mean income is less than or greater than 31,666. Let's look at our next example. On the next example, we have a student group that maintains that the average travel time of the students one way to campus is 25 minutes. Now, that's the established belief, is that the one-way travel time is 25 minutes. Now, the college admissions office, however, actually collected a random sample of 31 one-way travel times. And based on that sample, they found that the mean was 19.4 minutes and the standard deviation was 9.6 minutes. So at this point, we would like to state the null and the alternate hypothesis. So the null hypothesis is going to support what the student group maintains. And so that is going to say that the average travel time one way is 25 minutes. Now, the alternate hypothesis is going to be what the college admissions office is trying to say. And that is that the travel time is actually less than 25 minutes, because in their sample they came up with 19.4 minutes as an average based on their sample of 31. So they're going to contend that the travel time is really less than 25 minutes for their campus. So the hypotheses are, the null hypothesis is that the mean travel time is 25 minutes, and the alternate is that the mean travel time is less than 25 minutes. And just again as an aside, because we're saying less than, on the standard normal curve, we're talking about an area to the left, which is going to make this a left-tailed test.